Let's create a DFA for this language W, where W has an even number of A's and 1 or 2 B's. So one of the first things we can notice when looking at this language is that it is the intersection of two languages. So we have this first language where W has an even number of A's, and we have the second language where W has 1 or 2 B's. We need to understand the DFAs for both of these, and then we can combine them into one DFA. That makes it easier if we understand the root of the problem. So let's start first with this DFA here. W has an even number of A's. So we have our initial state as we always do. We'll call this state 1. And then if we have an input string, our language, our alphabet here is going to be A comma B. So if we have a string consisting of A's and B's, we'll just say A, B, B, A, B. If we're feeding it into our DFA here, where do we want to go on, say we have an A as our first string that we're feeding into? Let's create a transition to go to a new state. So when we have an A, we go to a new state, state 2. What does this tell us? Well, this tells us that we have exactly one A. And then if we were to have another transition from state 2 to state 3, then we need an A to get to state 2, and then another A to get to state 3. So that means we have two A's. But that's not the problem we're going for. We're looking for an even number of A's. So say we have a string A, which has an even number of A's, 4 A's. How are we going to determine if it's even or not? Well, what we can do is we can, upon state 2, if we have an A, we go backwards, back to state 1 if we have another A. What this does is we need exactly one A to go to state 2. Then on the second A, we go back to state 1. On the third A, we go back to state 2. Fourth A, we go back to state 1. Do you see what's happening here? When we have 0 A's, 2 A's, 4 A's, etc., we're on state 1. But if we have 1 A, 3 A's, 5 A's, and so on, we're on state 2. So now we're keeping track of if we have an even or odd number of A's. And our except state is going to be the state where we have an even number of A's always. So that's going to be state 1. Cool, I hope that makes sense. Let's move on to this next DFA here where W has 1 or 2 B's. So remember earlier how I was kind of counting the A's? We hop to state 2, then we hop to state 3, and that's kind of like we have 1 A and then we have 2 A's. Well, that's going to be very useful here. So let's create our initial state, state 1, and then on B's, we're talking about B this time, we need 1 or 2 B's, not A's. So when we have a B, we go to state 2. So when we're on state 2, that means we have exactly one B. Then if we transition again to a state 3, that means we have exactly 2 B's. Now this language requires we have 1 or 2 B's. So if we have another B, we should transition again to a new state. We'll call this state 4. State 4 means we have 3 B's. And is that valid? No. But I have a question for you. Is 4 B's, 5 B's, 17 B's, 26 B's, is that valid? No. The reason why I say that is when we get to state 4, that means we have 3 B's, and no amount of B's or A's can possibly make this valid. So we're going to have this as a dead state, meaning we're going to repeat, we're going to loop on everything, and it's never going to accept. Because once we've passed 2 B's, we have more than 2 B's, it's never going to be valid. So what is our accept state going to be here? Our accept state is going to be where we have 1 or 2 B's. So when we're on state 2, that's when we have 1 B. And when we're on state 3, that's when we have 2 B's. So that's going to be our accept state. Now, in every DFA, we need the whole alphabet coming out as an arrow from every state. So we need a A arrow and a B arrow coming out of every state. Let's check our DFAs to make sure that that's right. So we have an A arrow coming out of state 1, but no B arrow. So what do we want to do on B on state 1? Well, B is not really in this equation whatsoever. B doesn't contribute to anything. So we can just loop on B, meaning that we stay in place whenever a B happens. And the same thing can be said for state 2. B is not really relevant in this problem at all. Now, what about this second DFA? We have a B arrow coming out of state 1, but no A arrow. Where are we going to go on when we have an A? Well, A is not even in this equation whatsoever, similar to the first DFA where B was not in the equation. A doesn't contribute to anything here, it's not relevant. So we can just loop on A on every state. Perfect. So when we encounter an A, we just stay in place. We don't do anything because it's not relevant. Okay, so those are the final DFAs for these two languages. Now what we can do is we can combine these concepts and create one big DFA for this entire language. And you'll notice it's going to look very similar to, it's going to make sense that I combined those two that I did earlier. So now in red, we're going to do this whole entire language where W has an even number of A's and 1 or 2 B's. So let's have a initial state here. We'll call this state 1. And now let's first focus on, let's track if we have 1 or 2 B's. So we already know how to do this. We're going to set up our DFA for tracking if we have 1 or 2 B's. So if we're on state 2, we have 1 B. If we're on state 3, we have 2 B's. And then if we're on state 4, then we have 3 or more B's. And we're going to loop on A comma B. Now, the question here is, how do we incorporate this language here, where W has an even number of A's, into the same DFA? Well, what we can do is add another kind of dimension here, another row of states. So if we have another row of states, say we have a state 5 right here, what we can do is when we're on this row here, that means we have an even number of A's, and when we're on this row here, that means we have an odd number of A's. So we kind of set it up into two different rows here. And what I mean by this is on transition A, so say we have an A, we want to go downwards, essentially meaning that we want to switch from the row where we have an even number of A's to the row where we have an odd number of A's. So we can create a state here. We'll move this state 5 over here. So we'll call this state 5, and on transition A, we go to state 5, and then on A, we go back up to state 1. Now this is essentially what we had remember when we made the DFA for this language on its own, this is essentially what we had here. We're just switching rows based on how many A's we have. And we can continue this across the entire diagram because A is not factored into our equation at all besides counting if it's even or odd. So on every state, if we have an A, we're going to flip to the other side. So we're going to do the same thing for state 2. And we'll create a new state, state 6. And same thing for state 3. Creating a new state, state 7. Now we're not going to do it for state 4 because this is the dead state. That means we have 3 or more B's, so this entire language cannot be accepted. So, but as I told you earlier, we need a B and an A arrow coming out of every state because our alphabet is A comma B. So you'll notice here states 5, 6, and 7 only have A arrows coming out of them. So where do we go if we're on state 5 and we have a B? Well, we can just keep moving to the right because essentially what's happening here is on this x-axis here, we are counting how many B's. And then on this y-axis here, we're counting if the A's are even or odd. So we can still keep moving to the right when we have a B, even if we're on a different row. So we need a B transition from state 7. We can just send it to the dead state as well because we need 3 B's to get here, either path we take. So it'll always end up on the dead state and not accept. So let's test some input strings. So first let's test, we'll test something like ABAA, which does not accept. I'll put an X, meaning it should not accept. Let's do AAA, BBB, and we'll do one that does accept. So an even number of A's and 1 or 2 B's. So we'll do A, B, A. So these all should not accept, and this should accept. Because 3 A's is not an even number of A's, nor does it have 1 or 2 B's. It has 0 B's. And then BBB is 3 B's, so that doesn't meet our 1 or 2 B's requirement. So starting with ABAA, we start at our initial state, and then on A, we go to state 5, and then on B, we go to state 6, and then on A, we go to state 2, and then on A, we go to back to state 6. And this is not an accepting state, so this should be good. I forgot to put my accept states before I started testing. Let me put those in real quick. I'll fix my diagram. So our accept states are going to be essentially where both of these languages are true. So we have an even number of A's, remember, when we're on this row here, this first row, we have an even number of A's. And we have 1 or 2 B's when we're on states 2 or 3. So I'm going to highlight the even number of A's accepting states with orange, and then I'm going to highlight the 1 or 2 B's accepting states with green. So we want to accept where we accept on both languages. So this would be states 2 and 3 are going to be our accept states. Cool. So let's continue testing. So ABAA we already determined is not accepting, which is perfect. It landed on state 6. Now for AAA, we first start with our initial state. We go down to state 5. We go back up to state 1. Then we go back down to state 5. This is not accepting, and we want to not accept, so that's good. Now we have BBB. So for BBB, we're going to go from state 1 to state 2, then state 2 to state 3, then state 3 to state 4. And this is not accepting, so this is good. This is valid. Now we have ABA. So we're going to go, let me delete my orange here so I can use it again. We're going to go first, I'll delete the green too to make it easier. So we're going to go first to state 5, and then we have a B, so we're going to go from state 5 to state 6, and then we have an A, so we're going to go back up to state 2. And this is an accepting state, so that makes sense, that's what we want. Cool, so this is the DFA for the language W, where W has an even number of A's and 1 or 2 B's. I hope this made sense and taught you something, and best of luck with whatever you're using this for. Feel free to ask any questions in the comments.